Hello. My roommate Patrick has just given me a large muffin. He says he doesn't like them very much, which is great because I love muffins. But this muffin is very large, and I'm not sure if I want to eat the whole thing. So I'm going to cut it into a fraction of the muffin and only eat the fraction of the muffin, but I'm not sure how much it is that I'll be eating. I mean, how can I tell? There aren't any lines that are dividing this muffin up into equal parts, so how am I going to know how much of the muffin I've eaten? Let's take a look a little closer into that, and then hopefully I can use that knowledge to solve my muffin problem.
Let's start off by looking at these two rectangles. And the question I want to ask you is the rectangle on the bottom having the same fraction shaded in as the rectangle on the top? Yes? Yes, you're right. It does. But how can you tell? Well, the rectangle on the bottom, you can definitely tell what fraction is shaded in. There are 5 equal pieces. 2 of them are shaded in 2/5. But the rectangle on the top also has 2/5 shaded in. It's just that the equal pieces aren't shown for you. But you can tell because you can compare it to the one on the bottom. You can draw those lines in your mind. You could draw those lines that divide it up into 5 equal pieces just by imagining it, or if you had a marker and drew it on your laptop or phone or whatever you're looking at. Please don't do that, by the way. It's hard to erase that marker. Let's look at another example. So the question again is, do these two shapes both have the same fraction shaded in? And the answer is yes. And you can tell what fraction it is by looking at the one on the left. So this is a hexagon, and so there are 6 equal pieces. One of them is shaded in, so 1/6. The shape on the right also has 1/6 shaded in. You just can't see the division from the lines that broke it up into equal pieces. But you can imagine it in your mind, or you can just compare it to the one on the left. Okay, so let's give you a chance to try them out. These shapes are from Jump Math. Thanks, Jump Math, for giving me these shapes. They're awesome. So I'm going to give you some time to draw those lines in your mind. And the idea is that you want to break the shape up into equal pieces. They're not currently broken up into equal pieces, but you can imagine that they are. After that, I'm going to give you some time to check your answers by showing you how I divided each one. So, press pause now, and then press play when you're ready to check your answers. You ready to check? Okay, let's take a look at the one on the left. Well, the one on the left looks like the bottom half of the rectangle is broken up into 3 more rectangles. So let's just do the same thing on the top. Whoop, whoop. There we go. Okay, so how many equal pieces? Oh, we have to draw a fraction line. There's our fraction line. How many equal pieces? Looks like there are 6 equal pieces. 2 of them are shaded in. 2/6. Great. Let's do the one on the upper right. Again, it looks like the bottom part has extra rectangles divided up, so we just need to make those same lines on the top. Here we go. Whoop. There we go. Now they are equal pieces. Okay, so let's start making our fraction. Draw the fraction line, and now how many pieces are there altogether? 4 on the bottom, 4 on the top. 4 plus 4 is 8. 8 pieces. And how many are colored in? 2. 2/8. Okay, shape on the bottom, right. Okay, well, it looks like there are lines going from the vertices of the shape to the center. So if we just drew all of those lines from the vertices to the center, it would look something like that. Or actually, I drew them from the center to the vertices, but it's the same thing. Okay, those are equal shapes. How many are there? Oh, let's draw a fraction line first. Fraction line. You thought it was going to be on the right, but I put it on the left, just to keep you on your toes. So, how many are there altogether in terms of the equal shapes? 1, 2, 3, 4, 5, 6, 7, 8. 8 equal shapes. How many are shaded in? 3. 3/8. And finally, our shape on the right. Well, that one's pretty easy, actually. You just need to extend that horizontal line all the way through. Whoop. And now there are how many equal shapes? 6. So let's draw our fraction line. And 6 equal shapes. How many are shaded in? 1, 2, 3, 4, 5. 5/6. Let's try 3 more. Again, I'm going to give you some time to figure it out, so press pause and then press play when you're ready to test out if you got them right. Okay, welcome back. Let's take a look at the one on the top first. Looks like 2 hexagons. Nope, it's not 2 hexagons, it's 2 octagons. I don't know why I said hexagons. They look like a stop sign. So, if we were to just draw a line down the middle, there we go. You can clearly see there are 2 octagons. And now we can just do the same thing we did with the other octagons on the previous example. Draw some lines from the middle point to the vertices. Whoop, whoop. Okay, how many parts are there altogether? Well, there are 8 on the left and 8 on the right, so I'm going to guess 16. Let's draw a fraction line, and 16. Okay, and then how many are shaded in? Well, I just see 1, so 1/16. Bottom left corner, well, looks like those rectangles are divided up by drawing a diagonal line from one vertex to the other, so let's just do that on all of them. Well, first let's extend this one upwards. Yeah, okay, and let's do the rest of them. Ta-da! Okay. Now, how many parts does that leave us? 2, 4, 6 on the bottom, 6 on the top. That's 12 equal parts. So draw our fraction line. 12 equal parts. And how many are shaded in? 1, 2, 3. Okay. Last one on the right. Hard to say, but it looks like more of these diagonal lines. Let's try drawing a diagonal line. Yes, but they're not all equal parts yet. So I think we need to draw one more line to divide those bigger triangles into smaller triangles. There we go. Now they're equal parts. Okay. How many equal parts? 2, 4, 6, 8. 8 equal parts. Draw our fraction line. And how many equal parts? 8. How many shaded in? 2. 2/8. So that's how you can do this in your mind. All the dotted lines that I've shown you are just the dotted lines that I drew in my mind as I was trying to figure this out. So what's another way that we can deal with shapes and how we can break up the shapes into equal parts to find out what fraction they are? Well, I want to introduce you to my friends, the tangrams. This is a tangram set. It's sort of a puzzle kind of set that you can use to make different designs and different patterns. A small story to tell you, which is that when I was in elementary school, we weren't allowed to play on the internet when we were finished doing our work on the computer. We had to play the games that were pre-installed on the computer, and one of them was called Tangram, and so we would sit there and try and figure out how to make different patterns and puzzles using tangrams and cry because we wish we were playing something on the internet instead. Anyways, that's a story from my sad life as a grade 5 student. Let's get back to your life as a grade 5 student by answering a few questions about these tangrams, because one of the interesting things about these set of shapes is that you can use the smallest triangle to make the rest of the shapes, which of course leads to the question, what fraction is the smallest triangle of the rest of the shapes? So let's take a look. You could first ask what fraction of the square is the small triangle. And if you actually had these tangrams in front of you because you were in school rather than watching this video from home, then you would actually be able to move them around and figure it out. But you don't. So instead, I'm going to move them around with the powers of animation. Okay, so I've moved the blue triangle over top of the yellow square, and it looks to me like you could make the yellow square using 2 of these small triangles. So I would say there are 2 pieces altogether, and one of them is the triangle, so 1/2. The triangle is 1/2 of the yellow square. What about the next question? What fraction of the large triangle is the small triangle? Well, that's a bit harder, but I think I can do it. So first I'm going to move that one there, and I still haven't divided up into equal parts, so let's move another one. Oh, I have to rotate it. Okay, so now it looks like I have divided the large triangle up into equal parts using the small triangle. How many equal parts? Looks like 4. 1, 2, 3, 4. Yep. So 4 equal parts. And then if you were just to compare that to one of the triangles, you would say that the small triangle is 1/4 or 1/4 of the large triangle. Next question. What fraction of the medium triangle is a small triangle? Okay, well, let's move it over. There we go. And so you can see that I have divided the medium triangle into 2 smaller triangles. So you can say that there are 2 equal pieces. One of them would be the small triangle. So the small triangle is 1/2 of the medium triangle. What about the parallelogram? And if you can't remember what a parallelogram is, I'll give you a hint. It's the purple one. So what fraction of the parallelogram is the small triangle? Well, let's just move it down. Looks like the parallelogram can also be made of 2 small triangles. So even though it's not the same shape as the medium triangle, it uses the same number of small triangles. So you can use 2 small triangles to make the parallelogram. So 2 equal pieces. One of them would be the triangle. So the parallelogram is, or the small triangle is 1/2 of the parallelogram. And so now that we know that, I'm going to give you some questions to solve. So it's actually the same question, but different arrangements of the shapes. So the question for all of them is, what fraction of the shape is the small blue triangle? So press pause, figure them all out, and then press play when you're ready to see the answers. Ready to see the answers? Okay, so let's draw our fraction line and look at the first puzzle over here. So here's the blue triangle, and let's count how many pieces altogether you would have if you divided this into blue triangles. Well, I know that the square is 2 blue triangles, so 1, 2. I know that the medium triangle is 2 blue triangles, so 3, 4. I know the parallelogram is 2 blue triangles, 5, 6. And then the small triangles themselves, 7, 8. So there are 8 pieces altogether if we were to divide this up. So 8 pieces altogether, and there's only 1 blue triangle, so 1/8. Let's move over to the puzzle on the right. Well, again, we can divide these up. Let's look at the medium triangles. That's 1, 2 small triangles, 3, 4 small triangles. The parallelograms are also 2 small triangles, so 5, 6, 7, 8. And then counting the small triangles themselves, 9, 10. So there are 10 pieces altogether, and only one of them is the blue triangle. Don't count this one as a blue triangle. It's the same shape, it's the same size, but it is not a blue triangle, so it doesn't count. Okay, so 1/10 of this shape is the small blue triangle. What about the one on the bottom? Well, the one on the bottom. Well, let's go from left to right. So the square is 1, 2 small triangles, 3, 4, 5, 6, 7, 8. So 8 pieces altogether, just like the one on the top left. And in fact, if you take a look, you will see that they are made of the exact same shapes, just a different arrangement. And that's the kind of cool thing about tangrams. You can make all these different patterns and different shapes of patterns and different shapes in general just by rearranging the tangrams. Okay, how many of them are blue? Well, it's just the 1 blue triangle, so 1/8. Let's try a few more. Ooh, now we're using the large triangles. Now remember, the large triangles are how many small triangles? 4. So remember that when you're trying to figure out the answer to the question at the top. Press pause now, and then press play when you're ready to hear the answers. Okay, so let's start with the one on the left. We know that the large triangle is worth 4 small triangles, so 4, 8, and then the square is 2, so 9, 10, 11. Oh, and I'm just pointing out in case you forgot, yes, it is for small triangles. Just proving that to you in case your mind is having a hard time dividing it up. Okay, thanks for that. So there are 11 pieces that are equal size. And then how many of them are the blue triangle? Well, just the one. Okay, what about the one on the right? Let's draw our fraction line. Okay, and then let's count. So again, 4, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 equal pieces. And then one shaded in. No, not one shaded in. One that's blue. Sorry, I was thinking back to the one from before. One that's blue. The one small blue triangle. And finally, you can do this with flags. Here's the flag of Finland. Well, it's not exactly the flag of Finland. I made a small adjustment to it so that it would fit into my question. So I hope any Finnish people out there watching me will forgive me. And I'm so sorry, but I needed to make this work for math. Interesting side story. The Finnish word for Finland is Suomi. Suomi. Just in case you were wondering. All right, so how can we divide this into equal parts? Well, I'm looking at that wedge on the bottom there, the blue wedge. I'm just wondering if I could break the rest of the flag up into rectangles that are the same size. Let's find out. First, let's isolate that rectangle. So far, so good. And then let's see if the rest of the vertical line there is made of rectangles that size. It is. Okay, and now we'll just draw lines, vertical lines along the rest of the flag just to check. Great, it looks like the entire flag can be divided into rectangles that are the same size. How many of them are there? Well, looking along the bottom, 1, 2, 3, 4, 5, 6. Okay, and 6 times 3, 6, 12, 18. Okay, so there are 18 pieces altogether. Let's draw our fraction line. And 18 pieces altogether. And then how many are colored in? 1, 2, 3, 4, 5, 6, 7, 8. 8 18ths. So that's how you can use your mind to divide up images and shapes, even if they're not actually divided up into equal pieces. And that way you can find out the fractions by imagining that they are equal pieces. I wonder how I can use that to apply it to my muffin problem. Let's take a look.
Okay, so now that I know about that, I think I'm going to put the muffin down on the table and see if I can use what I've learned to figure out what fraction of the muffin I've cut. So here's the muffin, and I think I only want to eat this much. So I'm going to make a slice here. I'm going to make a slice there. I'm going to take that part of the muffin out for eating. But how much did I actually take? Well, one of the things we can do is, if there aren't any lines that show the equal parts, we can make our own lines. So let's do that now. I'm going to cut the rest of it into equal parts that are the same size as the slice that I've taken out. Can you see the parts? Let's take a look. So we have to count all of the equal parts, including the one that I've taken out. 1, 2, 3, 4, 5, and then the last one is 6. So if we cut into 6 equal parts and then took 1 away, that would be 6 equal parts, 1 taken away, 1/6. Well, I'm going to enjoy my 1/6 of a muffin. What are you going to do? First, I want you to complete page 202 in your Jump Math workbook that I've sent home. And secondly, if you want to keep playing around with tangrams, please go to mypuzzle.org/tangram, and there are a whole bunch of tangram challenges, and it's something you can do to improve your geometric thinking and improve your ability to imagine how some shapes fit into other shapes, which is very useful when you're thinking about fractions of things, including muffins. I'm going to enjoy my muffin, and you're going to enjoy your math. Bye!